Hey, good morning, and welcome to the ZP Vlog on Podcast. So we like to do this vlog on podcast once a week, and it's really just a summary of the news from ZP for this week. So we'd like to do it on a Sunday at 8 a.m. London time, and we're approximately at that time, so we'll go ahead and move forward. So one of the things that we talked about those this week was something really covering for all those who want to manufacture electrochemical products. So at ZP, I think a big part of our business model is to really help people get to market. Now we try to help people get to market by um, reducing the technology barriers that prevent them from getting to market. So we try to come up with technologies that say, okay, here's your screen printed electrodes, or here's your biosensor, or here's your electronics. And one of the systems that we do have for allowing people to do that is this single purpose biosensor circuit. It's really quite neat. It's a fully shielded potentiostat, but it's more than a potentiostat because it has what they call analog front end, a digital back end, and it allows people to electronically connect with electrochemical sensors. This is definitely something for another time, but I do feel like the modality for test, one of the best modalities for test in the world is electrochemistry. You have fluorescence, you have absorption spectroscopy, you can have Raman spectroscopy, you can have surface plasma resonance, but generally for me, if you're trying to make a chemical and biological measurement, then I think electrochemistry is really good. And I suppose the single purpose biosensor circuit actually shows one of the reasons why, and that's because it has it's a fairly small form factor, and it's very hard to think of many modalities where actually you can make electronics that are so small and they will still essentially work. So we did talk about the single purpose biosensor circuit this week. Something else that we talked about, this is just as relevant actually to the whole philosophy at ZP, is really about technology readiness levels. Technology readiness levels is something that was originally invented at NASA, and it's really a good concept. It's just a way of being able to sort of try and quantify where a technology really is at, because people sort of talk about their technology, and some people sort of hype up its preparedness, and some people are kind of more modest, let's say, on their technology's readiness. But at ZP, we use the NASA scale. So there's a NASA scale of kind of 1 to 9, and 9 obviously being the highest, and 1 really just being sort of the ideas stage. And so at ZP, we do apply that so that we can have a kind of a grounding with our clients or our collaborators as to where the technology really is at. And you'll see that funders these days are also adopting this kind of technology readiness level. So funders will sometimes, depending on the source of funding, they may only fund 1 to 4. They may only fund sort of 4 to 8. It's very rarely people fund 9. And the reason being is once you're 9, then they think, well, you're commercially ready. So they want to sort of fund earlier on. But if they was kind of basic research, then they would kind of be, calling it 1 and 2. And if it was kind of more technology readiness for development rather, they'd be saying 4 and 5. So we do use a technology readiness level at ZP. It's not something we've invented. It is more commonly applied these days. But something that's not commonly applied is the manufacturing readiness level. It's probably worth saying that you can have a really good or really high technology readiness level. It doesn't necessarily mean that you've really considered the manufacturing readiness level. I do feel like these two things are kind of hand in hand with one another. But you can have a high technology readiness level in terms of if you were making a satellite, especially let's say a satellite that was going to orbit Jupiter, that might be a one-off technology, or at least a one-off system. So therefore, you don't need a super high manufacturing readiness level on that, because you're not going to manufacture it, you're just going to assemble it. Whereas if you're trying to obviously make a low-cost biosensor system, the manufacturing readiness level is really important. So there is also a manufacturing readiness level, but that manufacturing readiness level assumes that your technology readiness is already high, and now you're ready to manufacture it. So at ZP, I would argue that many of our sensors and technologies have good technology readiness levels and good manufacturing readiness levels. The thing that then comes up then is really application readiness levels. And application readiness level kind of says that, well, you may have a good, let's say, sensor, and you may have the ability to manufacture it, but do you have the capability of delivering it to my application. Let's say it's a blood gas analyzer, and in that case, ZP would be saying, right, well, we have to find out what the application is. So there may be still a gap, in your ability to go to market. So the gap may become because actually you want to manufacture. Let me think of something that's quite tough, like the phosphate in river water or the phosphate in soil. These are tough applications. So even though ZP does actually have the electronics and the sensors for phosphate, whether you can continually measure phosphate in a flowing river, for example, for several months, that's a different. That's an application, and we wouldn't have gather the data for that. So therefore you have a gap in your application readiness level. And that also goes from 1 to 9 as well. So technology readiness level, manufacturing readiness level, and application readiness level, they're kind of, they all define different things, but they do kind of click together. And then I think it's really interesting because I think that when you're doing a startup, you need a sort of technology, you need a manufacturing, you need an application, but actually you've got this business readiness level as well. It's funny because all businesses are sort of treated the same way, but you can have a business readiness that's just one, which is just sort of the idea. You can have 3, which is really when you've got let's say a business plan. 5 when the key assumptions are sort of tested. But really, again, there's a grade of sort of 1 to 9 here, and sort of if you want to be a business readiness level number 9, it means you've actually been in business and you've been selling and making revenues and hopefully in profit. So very few, let's say, startup businesses are really business readiness level number 9. In fact, I'd argue most of them are on 5 or 6, especially in the sort of startup community. If you're VC funded, by nature, you're not really sustainable on your customers because you're funded, by an investor. You're not funded, or you haven't got enough customers to actually keep you afloat. So business readiness level is also a kind of useful parameter as well. When I say all of this, of course, we do have individual videos on the websites about these different business readiness levels. I suppose this is a good case, actually. We also did cover in our Sense It All webinar. So every week we do a Sense It All webinar. So on Mondays we do Sense It All. On Tuesdays we do Julie. On Wednesdays we do Food Sense, and on Thursdays we do ZP Technology. So every morning we do have webinars covering the various technologies that we have at ZP, and on Mondays we do Sense It All. And this week we did cover precision fermentation. So precision fermentation is really, you have fermentation where traditionally it was yeast was kind of making alcohol in the brewing industry. But fermentation / bioreactors can also be about reprogramming these, I want to say, organisms to make more useful, well, not more useful, but make specific products through, you molecular engineer them, and then they will sort of essentially make you that product. At ZP, we're very interested in sort of glucose and oxygen and pH, and also conductivity, and all these things can be used to measure the conditions within that fermentation. And if you can measure the conditions within a fermentation, then that means you can actually control it. pH is an easy one. If the pH is suboptimal, then you can add acid or base to kind of bring the pH back again. I mean, this is done through having pH sensors with controllers linked to pumps, and you can pump in the acid and base accordingly. So at ZP, obviously, we do have these sensors. Glucose, oxygen, pH, and conductivity. So we can measure these parameters, and then using pumps, you can actually affect the parameters to essentially keep the parameter within a set point. So we did discuss precision fermentation this week. At ZP, we're very interested in control, because control starts with measurement, and measurement can often start with sensors. I did mention that we do these weekly webinars, so we definitely did do our Julie webinar this week. This week we actually talked again about, there's a small potential stat out there from a company called Galvanoplot. It has a file format called GPE. We showed how we could upload their data to the Julie cloud just by changing the file name or the file suffix from GPE, which is, I think, some sort of system that they've invented, to a TXT or a text file. And then I was able to edit that text file in Excel and show that we could upload the data. So it really unlocks the value of both their Potentiostat, and also shows the kind of flexibility of Julie as well. Something else that we put up this week as well is that ZP, the nice thing about ZP is, I was talking about manufacturing readiness level earlier on. At ZP, we're constantly manufacturing sensors, so that means we can actually keep our manufacturing readiness levels high. If you, let's say, develop something and then you kind of don't touch it for a couple of years, then your manufacturing readiness level is deteriorating. You can't just turn it back on. You have to kind of, for manufacturing to be ready, you have to really be doing it. So that said, we were talking about our wire electrodes recently. We have these wire electrodes also for pH, which is funny because it plays back into that precision fermentation that I was talking about a minute ago. But we did put some data out there as well. I mean, it's, these pH sensors that we're describing in our websites. I mean, these are really on the scale of human hairs. So they're really tiny, really kind of non-intrusive, and probably perfect for actually microfluidic applications when I really think about it. And then I suppose finally, every Thursday at 8 a.m. London time, ZP likes to do a webinar, really just talking about broadly our technology. So we have these kind of 4 webinars: Sense It All Monday, Julie, which is our cloud system, on Tuesdays, Food Sensor on Wednesdays, which is really one of our sort of flagship products for measuring the hotness of chilies. And then on Thursdays, there's the technology that kind of underpins all these technologies, and we like to cover that on a Thursday webinar. So we do have a webinar on Thursday, the 19th of October, and we will cover any questions that have come in for the week. So I think that sums up ZP's vlog and podcast for this week. So you can see it's been a lot about manufacturing this week and technology readiness levels, but just by helping people to understand that journey from idea to actually product. And I suppose when you strip back ZP so many times, what you're going to find out is that we're really all about helping people understand the science, but understanding the science with a purpose, which is actually to get them to market. So I would put it this way: if you've got any questions on ZP, don't hesitate to reach out to us. It's probably worth saying that we have I'm going to East Coast USA this week, and we're going to do a corporate workshop where we're going on somebody's site, and we're going to spend the day with them, teaching them all about biosensing, fabricating some biosensors, testing some biosensors with them. So if you'd like to have ZP on site with you, don't hesitate to reach out to us, and maybe we can organise it. Okay, I'll leave it at that, but thanks very much, and as again, don't hesitate to reach out if you've got any questions. Okay, thank you very much.